Good to see everyone here. Today, we have no shortage of tech that's amazingly helpful. We also have a few things that are transformational. Hello folks, my name is Sajid Sadi. I'm SVP of Research at Samsung, head of the think tank team, and chief executive at Neon. Today, I'd like to tell you why we need more transformational AI. So let's unpack that a little bit. What does it really mean to be transformational? Well, I used a few sci-fi references in the intro, so let's go with that for a bit, huh? First, we have things that are at least contextually unhelpful. So a good example of this would be this here targeting computer from Star Wars. We all remember the trench run, all the shots going by, turning off the computer. Since no one was targeting with the computer and actually managed to hit the target, I think we can all agree to its ignominious state. It's not that it doesn't work, but its properties are unhelpful in the context of its use. So that's unhelpful. Then we get to helpful stuff. The computer from Star Trek: The Next Generation falls pretty nicely in this category. It's not very flashy, and it's even not called AI. I'll talk to that when we get to contextualizing this time period. It answers some questions, turns on the lights, makes you tea. Pretty helpful. Turns out Star Trek not only invented the tablet, it also invented the modern voice assistant. Not bad. We'll get back to this one. Now we get to the fun stuff, transformational. Transformational is when you turn Mr. Grumpy into Mr. Happy. Transformational is when you change the behavior and outlook of people. Let's look at some data points to underscore that business side. Let's look at some data points to underscore the business side. We'll do hand tools, literally the thing that made humans, well, human. The global retail yearly sales of hand and power tools is about, give or take, 38 billion in 2020. So let's talk about an even more kind of common hand tool, the smartphone. The smartphone market is worth well north of 409 billion. And actually it used to be higher. It's gone down a bit. We can certainly argue that phone has more features, does more, and so on. But ultimately, it is a tool that lets you do things. And I don't think we can have any disagreement that the smartphone has transformed not just how we do things, but what we do. And even how we make a living. Social media influencer, anybody? So that's one way of thinking about transformational. So again, what does it really mean to be transformational? I'll offer you this opinion, perhaps without much proof. It's something that actually comes from the field of coaching. And they usually say that when something is helpful, it's letting you be a better version of your current you. When something is transformational, it's helping you become a different and hopefully much better version of the future you. All right, so with that preface, let's get into AI. And more specifically, let's get into machine learning, which is really the engine that powers AI as we know it today. I'll preface it again by saying that these are my personal opinions on what is clearly a very hot area, so please direct your ire appropriately. So let me state my opinion. Incrementalism is hobbling AI. To understand why I think that, let me take you back down memory lane once again to the 1950s. Now, that's prior to my memory, but I'm a big believer in learning from history, so bear with me. Basically, AI has been here before. Here is where we are today. AI has undergone repeated iterations of booms and stagnations, what we call AI winters, and I think you guys all know about it. You can think of it as a repeated application of kind of the Gartner hype cycle, if you know about that. The first cycle was triggered by digital tech post-World War II and promised that compute would lead to thinking machines. This was the era of good old-fashioned AI or symbolic AI, where we thought that the faster and smarter manipulation of symbols would lead to something that was akin to artificial consciousness. Fueled by fears of communism, it was well-fed by ARPA and DARPA. But by the early 70s, it was pretty clear it was not to be. But not to worry, even if the machines couldn't think, they could certainly solve certain kinds of problems better. Powered by the growing capacity of computers and the fear of globalization, especially from Japan, the next iteration came out in the late 70s, birthed by expert systems. By the late 80s, the level of expert performance was found again to be wanting, and we had a second winter of AI. And the third wave? That's where we are today. The trigger for that was basically the internet. The internet created big data in a way that was simply impossible before. Moore's law also hockey sticked the compute capability that we had access to, and storage became basically as cheap as water. So now we could crunch more data in less time, and we had more data. So the approach became statistical. And that is, of course, what has evolved into what we call machine learning today. So that's really the worry, that we will establish this stuff doesn't work mythos again, and that's what leads to stagnation. That's how we get into the hobbled growth curve. I really like this quote from Dan Crevier, who wrote a history for the first two AI winters back in about 1993. Many researchers were caught up in a web of increasing exaggeration. Their initial promises to DARPA had been much too optimistic. And of course, what they delivered stopped considerably short of that. But they felt they couldn't, in their proposal, promise less than the first one. So each time, they promised more. I, for one, would rather not go down that path again. We have made what promises we have made. So for the rest of this talk, I want to speak about how we can deliver more. So now let's get into the targets of AI improvement, how we do it today, how we could be doing it. Since one of the most common directly used forms of AI is the voice assistant, I'll pick that for an example. You'll see that the concerns are actually fully generalizable. It doesn't necessarily apply to only voice assistants. Also, I won't be talking about any specific solutions because they approximately all work in this way. So this is not about any particular implementation like Bixby or Siri or Google Assistant. So a quick refresher on how this works. You have audio utterances that goes through a TTS engine and maybe voice ID. The content is then routed to specific business logic. The business logic decides what to do, and it can reach out to provide external effects like turn on lights. And then it forms a response like, okay, I turned on the lights in the kitchen. And that's rendered back into audio. And finally, that is what you hear coming out of the speaker. And the thing is that other than the audio input and output, and even in the audio input and output, every other part definitely uses machine learning or AI to achieve its goals. So what's the issue? The main issue, I would say, is that the business logic isn't just one thing. It's actually a whole pile of things. We call these things Alexa skills, whatever you have. And when we set about improving the system, we improve it one at a time. Maybe we improve the TTS, or we improve what we do, or we improve playback, or response creation, or any number of other individual things. Basically, we improve it like it's an ML-assisted expert system. And like a system with many buttons, each one does its own thing. So we want to change the way the system works. We want to really be able to hold a chain of thought, if you will. The parts of the system that really need improvement are actually the interconnections between the parts. How things work together, not just how an individual piece works. So back to that helpful versus transformational thing. It's helpful to improve the parts. For example, so that the voice assistant understands you better. But it's transformational to improve the integrated effects. But voice assistants are already making really good money, honestly. So why do we need to do this? Well, because of this. Well, not her specifically, but namely because this anchor is not the actual anchor. This is a digital human replica. The different parts of AI are not operating in lockstep. Some parts are moving faster, some parts appear to be moving faster. So what we have is something that looks like this and thinks like this. Certainly, the digital anchor is at least useful, and the voice assistant is certainly helpful, we all know that. But when you add them together, you get the dreaded uncanny valley. On one hand, you have helpful, find me references to cats. On the other hand, you have transformational, give me a sense of human connection. In between, you have this uncanny valley of, I can smell it and it's not exactly what it looks like. It's not human. It's basically almost like an alien wearing a human suit. So that brings us to that same trigger that triggered all the previous AI winters. It's looks versus works. It's expectations versus reality. And I don't speak here about just AI speakers or digital assistants or virtual humans. It applies to all of the different forms. to automation, to robotics, self-driving cars, self-flying cars, you name it. So for the last bit, I'll talk about R&D. Today in research, we have really two aspects going on simultaneously. There's the part that does discovery within data, forging results out of OR data by the ton. And there's discovery about data, kind of a precision disassembly which lets you get to the heart of the data and maybe pluck out some insight. If we look at the field widely, which my several different jobs and hats require me to do, we really get to this. Breakthrough in insights, those are about massive data. It's about doing amazing data science and really digging in there. The primary work is about getting the data into the form that can be operated upon. Breakthroughs in models are really driven by insights about data. It's about sitting on a rock and thinking about what's happening, why it's happening, and what's needed. Let's look at that in a different way. When we train a model with a lot of data, we're teaching it as a system to do something. When we develop a model of operation, we're learning how to transform something as humans. We ourselves are learning. All these connections we talked about before, these can only be addressed with new kinds of models. But I hear you say, can't you just learn that from enough data? Certainly, we can. But what we end up getting is a form of convergent evolution. Believe it or not, the same form of C4 photosynthesis that's used by corn has been recreated by nature 40 different times that we know of. How we get there can be found by search or by observing. So going back to the two forms, a data-oriented approach is good for getting where you need to get. A model-centric approach is good for controlling how you get there, and also getting the right kind of knobs and understanding of how it worked. If we accept that we need to combine data and intuition to get a new kind of model, then first we need data. Most model building actually starts off with a small amount of data, and the reason is really simple. Insights come from people, and patterns come from computers. The guidance of how to form patterns, that still requires people to this day. And people cannot necessarily keep petabytes of information in their brain the way a computer does. That said, the data has to be good data. You will see time and again researchers using the same tired old data sets and models because the data and the model folks don't seem to really talk. And that's something that we definitely need to fix. But given that we have data, what does this process look like? Well, you only want to control something that matters. So actually, it all starts with observing needs. You need to look at people and see what do people really want. From there, we imagine that we could solve it, and we look at the methods, and we look at what can be convenient for computers. This lets us intuit approaches to fill the gaps that exist between the methods that we have today. That's really the building of the model. And finally, we have validation, where we get results. And we have to show compassion. We have to go back to the user and we have to ask the question, is this something that's actually useful for people? Do people want this? Is this the kind of result that we would be okay with? And finally, when we do get the results, we need to go back to the user and ask, is this the thing that's the stuff that you're looking for? Is this good in the human sense? We see, for example, a lot of things that are amazing progressions in deepfakes. But is that actually believable? Does it avoid the uncanny valley? Can you control it in a way that you care about? We need to think about those things as well. And when we develop models, that's really what needs to come front of mind for there to be models that people actually want to use, that provide value to the user. So, takeaways. We started off talking about why we need transformational changes in the approach to speed up the future of AI and ML. And simply put, what we want to do is avoid a future AI winter. Through the lens of voice assistants, I tried to show you how segregated approaches contribute to slowing down all our progress as a community. And I talked about a closed-loop, user-centric approach where we observe users and use our minds to create the models that have the right outcomes for real-world use. Because that's how we're being evaluated. By the rest of humanity outside of this room, the evaluation is based on use. So if there's a one-liner takeaway that I would like you to take from this talk, it is simply that observation informs intuition. Our minds are capable of great leaps. but only if we feed it the right information. And we can do that only by opening our eyes to the real phenomena that our AIs are operating upon. Thank you, and I'd love to take your questions.